We are going to be looking at 3 consecutive problems here from Section 2 out of Chapter 2. The main purpose of looking at these is to demonstrate and help you to learn how to input data, look at a scatter plot from data on the TI calculator, and then determine whether that scatter plot shows a linear relationship, and then finally how to proceed to get the linear regression equation. Before we get started, one of the things that I want to do is to set up the calculator, and so on the calculator that you see here, I am going to go to the Stat menu. I guess first I should turn it on. Going to the Stat menu, what I want to do is I want to clear out some lists because I am going to be putting the data from problem 6 into the calculator, and I think I will put it in list 1, so I'm going to hit second function L1, comma, second function L2. After I hit enter, this would clear out list 1 and 2. There's one other thing I would like to do, and you only have to do this one time. And so what we are going to do is we are going to turn on the diagnostic on. To do that, I need to go into the calculator, into the catalog. Catalog is above the 0, so I'm going to do second catalog. And I think if I click on alpha D here, I can get down to the D's for diagnostic. It did not work on my calculator. So I'm just going to scroll down, and I'm scrolling down to get to diagnostic on. I went a little too far. Here it is, diagnostic on. I'm going to hit enter, and diagnostic is now turned on, and we will leave it on for the rest of the course. You do not need to change this again. Now, the data that we see on the left side of the screen over here is the data that I am now going to input into the calculator. To do this, we will again hit Stat. We will hit enter because we are going to edit. And we can see that list 1 is totally clear. I am now going to put in the data under the X variable for list 1. So I press 1, enter, 2, enter, 3, enter. The next data value is 5, enter, 7, enter, 9, enter, and finally 12. We will scroll to the right now, and now we are under list 2, and in list 2 we will enter the Y values. The first one is 1, then 3, 6, 1 again, 9, 2, and finally 6. Notice that our lists are the same length. They must be to do what we need to do as we continue with problem number 6. To continue here, what we need to do is go to our stat plot. Stat plot is above y equals, so I hit second stat plot, and we are going to choose plot 1 and turn it on, and we will hit enter now to turn it on. Scrolling down, our scatter plot is the first of the options underneath the type. As you can see, our L1 is the X list, our L2 is the Y list, and our mark, you can choose either a little square, a plus sign, or just a plain dot. I like to use the square, so I'm going to leave it the way it is. We can now hit enter, and nothing more happened, but that's okay. The next thing we want to do before we try to plot this is we need to set up our window. So I'm going to click on Window, and notice that our X values range from 1 to a high of 12. So I'm going to choose 0, which is smaller than 1, and I'll go to, say, 13, which is larger than 12. A scale of 1 is good for this. Looking at our Y values, they have a minimum of 1, as we can see over here, and also a maximum of 9. So again, I'm going to start at 0, but this time I'm going to go past 9 to 10. And so this is an appropriate window for the data that we have in our data set for problem number 6. We are now ready to look at the scatter plot, but before I do that, one other thing you might want to check is just in your y equals menu. Do you have anything in the y values here? If so, you would want to delete any functions that you might already have here so that they do not interfere with what we're looking at next. Now we press graph, and this is a scatter plot for problem number 6. In problem number 6, they asked us to do this scatter plot, and this completes number 6. For problem number 8, they asked the question, can the scatter plot in exercise 6 be fitted exactly or only approximately by a linear function? Well, looking at these little squares on the screen, we will determine that this can only be approximately modeled by a linear function. In fact, the dots or the squares are all over the place, and so the linear regression line is actually not even going to be a very good fit for these lines. To find the linear regression line, which we are asked to do in problem number 10, we are going to go back to the Stat menu. This time we will scroll to the right, and underneath the Calc, we can pick out number 4 for the linear regression equation. We'll hit Enter, and what I like to do is to next tell the calculator where the data is. Our X values are in list 1, so I'll hit second list 1 with a comma, and then our Y values are in list 2. When I hit Enter, we will get the information that we are looking for. This is a linear regression of the form y equals ax plus b, where a would then be the slope of the line, which is approximately 0.282, and the b is the y-intercept. Rounding this to 3 significant digits, we would have 2.43. So therefore, our linear regression equation would be y equals 0.282 times x plus 2.43. Let's do one more thing with this that is not part of problem number 10. Let's add the line to our graph. Recall that this line we had was 0.282 times the x plus 2.43. And unlike the textbook, instead of keeping a specific number of decimal places, I think it is more appropriate to keep the same number of significant digits, and so that's what we see here. If I now press the graph key, this will add the regression line to the graph, and we can see that many of our plotted points from our scatter plot are not anywhere close to the line, so this is not a very good fit. If I go back to the Stat menu and do the Calc one more time just to show you what I'm talking about. Again, this is in list 1 and list 2. The thing that we look at to determine whether this is a good fit are the R values here. And over here we have an R value of 0.368, and we want an R value that is getting close to 1 or -1. In other words, the R squared would be close to 1. The R value is always going to be less than 1 but greater than -1, and the R squared will always be between 0 and 1. If the R squared value is 1, that means it is a perfect fit. Anything that's smaller than 1 is not a perfect fit, and the smaller the R squared is, the worse the fit. As we can look at our graph, we see this is not a good fit. This completes this particular exercise, looking at making a scatter plot, determining if we have an exact line by looking at the scatter plot, in determining the regression equation.